Hello and welcome to this session where we discuss the method of preparation of alkanes. Right, so clearly let's go systematically and see by what all ways we can prepare an alkane. So in this case our starting point can be a alkyl halide. If you have a alkyl halide, what we can do, we can convert this into the Grignard reagent. And how do we do that? We can just add magnesium in presence of ether. This converts to Grignard reagent. Now Grignard reagent is RMgX, right? And we know that Grignard reagent reacts with compound containing active hydrogen to give us alkane. Now what are compound containing active hydrogen? Active hydrogen means hydrogen attached to electronegative atom. Just like for example we have the hydrogen in H2O, this is attached to a electronegative atom. Or maybe ammonia, where hydrogen is attached to a electronegative atom nitrogen, right? Or hydrogen attached to carbon triple bond carbon. For example, if we have HC triple bond C and H, this would also be example of an active hydrogen. So it gives this reaction. Alternatively, we can also use the complex metal hydrides, like we can use LiAlH4, lithium aluminium hydride, SBH, sodium borohydrides, and so on. So we can use a complex metal hydrides. Alternatively, we can also use Wood's reaction. Now when we say a Wood's reaction basically, as you might be knowing, the reaction is, when we say the Wood's reaction is basically the reaction of two molecules of alkyl halide giving us a symmetrical alkane. So the limitation of the reaction is, in this reaction we get a symmetrical alkane. If we don't want that, and if we want the alkane to be asymmetrical, we have a reaction which is a Corey-House synthesis. Right? So Corey-House reaction can be used. Now if we say a Corey-House reaction, so in this Corey-House reaction we first convert this into alkyl lithium, okay, followed this will be RLi formation, right? And then reaction with CuI giving us Gilman's reagent. What is Gilman's reagent? Lithium dialkyl cuprate. So it is lithium, copper, and we have two molecules of R. Now the symmetricity can be introduced by reacting this further with a different alkyl halide. So ultimately we end up getting RR dash. So we can see over here it's a highly asymmetrical thing, so we can use this reaction. Alternatively, the preparation method of alkane can also start with the acids. So if we have acids, the carboxylic acid RCOH, right? So we have 2 or 3 methods to convert that into alkanes. If we have to preserve the number of carbons and we don't want to lose number of carbons, we have red phosphorus Hi reduction. So red phosphorus Hi would maintain the number of carbons. Second, we can also use a decarboxylation reaction. Now what is decarboxylation reaction? Heating in presence of soda lime. What is that? It's a mixture of NaOH and calcium oxide, but here you will get one carbon less. The third one is, you can also use the Kolb's electrolysis method. So we have the Kolbe's electrolysis method, right? So it can be used, and we can prepare, just like the Wood reaction, we can prepare a symmetrical alkane in this case. Also we can also prepare alkane from the carbonyl compounds. Now when we say carbonyl compounds, we means aldehyde and ketones. We have two name reactions over here. One is Clemenson's reduction, Clemenson and second reaction is a Wolff-Kishner reaction. So it is a Wolff-Kishner reaction, right? Now from alkenes also we can prepare alkanes, and it is just a hydrogenation reaction, also has a name, we call it Sabatier-Sandron reaction, right? So this is Sabatier-Sandron reaction. So this is basically a reaction flowchart where we talk about how we can prepare an alkane. So the starting point can be alkyl halide, it can be acid, it can be carbonyl compound, or it can be alkenes. We'll continue with the preparation methods of other functional groups shortly. Keep watching this video. Thanks.